So one final limiting reagent question. We need to know the mass of magnesium oxide, which is MgO. Possible if you have 2.40 grams of magnesium reacting with 10 grams of oxygen. This is almost exactly the same as example 2, where we're going to meld the limiting reagent concept with that of stoichiometry. So we first need to know how many moles of each substance we have. So we'll deal with magnesium first. Good news is with magnesium, it is a single element, so the molar mass is incredibly easy. Just look it up, and we have 24.305 grams per mole. Calculating the number of moles, mass divided by molar mass, so 2.40 divide 24.305 gives us 0.098745 moles of magnesium. Likewise, we need to calculate how many moles of oxygen we have. Not quite as easy for the molar mass of oxygen, but still one of the easier ones. 2 oxygen atoms weighing 15.999 gives us a molar mass of 31.998 grams per mole. And the number of moles of oxygen, mass 10.0 grams, divided by molar mass 31.998 gives us 0.31252 moles of O2. And again, we need to make an assumption that one of these two is the limiting reagent. It does not matter which one. I'm going to work with magnesium. I always generally work with the first substance that's given. It's just habit. So if we assume that would mean we use up all 0.098745 moles of magnesium. To determine how much oxygen that would actually require, we look back at the mole ratios. Magnesium has a 2 coefficient, oxygen has a 1. So multiply that by 1 mole of oxygen and 2 moles of magnesium. Do that calculation, we get out 0.0493725. This is how many moles of oxygen we have needed. Looking back, we see that we actually have 0.3 moles of oxygen, so we have well more than enough oxygen. So magnesium is the limiting reagent. So all of the magnesium gets used up. The amount of oxygen we have does not matter anymore. And now we can deal with the second part of this question, meaning how much magnesium oxide is possible. So we need to find how many moles of magnesium oxide we produce out of this magnesium. So we have used up 0.098745 moles of magnesium. Mole ratio again, but this time the mole ratio is to find how much magnesium oxide we create, looking at the coefficients. 2 moles of magnesium, 2 moles of magnesium oxide. So that will be what goes in our mole ratio calculation. Magnesium oxide on top, because that's what we're trying to find. Magnesium on the bottom. And the math works out quite easy for this one. It works out to 0.098745 moles of magnesium oxide that we produce. Now that we know how many moles of magnesium oxide, we can find the mass of magnesium oxide. To do that, we need its molar mass. So we have a single magnesium weighing 24.305, single oxygen weighing 15.999, molar mass of magnesium oxide, add those together, 40.304 grams per mole. And now that we know the molar mass, the mass of this substance is just our moles, 0.098745, multiplied by molar mass, 40.304. Rounding this to sig figs, we have 3 in the question, so we'll have 3 in the answer. 3.98, this is grams of magnesium oxide.